What are we going to do when we have a blue ocean event in the Arctic? By a blue ocean event, I mean an Arctic that is ice-free, or define it, if you like, as being under 1 million square kilometers of sea ice. Of course, the Arctic would be a much darker place. We wouldn't have that cap of that bright white ice and snow covering the Arctic Ocean. We'd have a very dark Arctic Ocean that absorbs a lot of sunlight, and the ice wouldn't be there to buffer the temperature, if you like. So it's likely that temperatures will skyrocket, and it won't end there. We'll have no sea ice at the end of the melt season, and then within a year or two, the duration will have been greatly extended to a month on either side or more. And then it's quite conceivable that within a decade or so, we have no sea ice at all in the Arctic, and we've transitioned through a abrupt climate change state to a much warmer planet. So I've been arguing for a long time that we have to treat the possibility of a blue ocean event in the Arctic as an utmost climate change emergency. And I've been suggesting that we apply a three-legged bar stool to arrest what is happening. So the first leg of the bar stool is that we need to zero fossil fuel emissions as much as possible. So Paris got everybody talking, but there are people, the powers that be are not recognizing the extent of the climate emergency that we're in. Temperatures rose about 0.85 degrees Celsius above pre-industrial, and this was a number that you probably heard a lot, from about 5 years ago, even 2 years ago. But what's happened now is that this year, 2016, the first 3 months of this year are off the charts in terms of temperature rise. In fact, for the entire month of February and March, we were close to that 1.5 degrees Celsius above pre-industrial. And in fact, for a day in March, I think March 3rd or something, we actually exceeded that 2-degree band for the entire northern hemisphere. So temperatures have been skyrocketing this year, and CO2 levels are also skyrocketing. In 2015, they rose about 3.08 or something parts per million, which is a record high amount, considering that there's been claims by the International Energy Agency, etc., that fossil fuel emissions have leveled off. So this is certainly not happening in terms of, it's the atmospheric levels that are important. And those levels are still rising sharply, not just for CO2, but for methane and nitrous oxide. So getting back to the three-legged bar stool metaphor, we have to zero fossil fuel emissions. The second leg of the bar stool is we need to cool the Arctic or the planet. We need to, if we let the Arctic continue to warm as it is, then the planet will change entirely. So we can apply methods like solar radiation management, cloud brightening, etc., to try to cool the Arctic, to keep the methane in place, and to cut off these cascading feedbacks that threaten to take us to a much warmer, unstable planet. We also need to apply, as a third leg of the bar stool, carbon dioxide removal methods. So we need to lower the CO2 levels in the atmosphere-ocean system, because ocean acidification is harming phytoplankton, which affects the entire food chain in the oceans. Not only that, but the warming and stratification of the oceans reduces mixing, and it's not just the nutrients that don't come up and sustain phytoplankton, it's the CO2 levels. The oxygen doesn't get down into the oceans, and this is a real threat to us. So we need to apply, on an emergency basis, the three-legged bar stool metaphor approach to stabilize the planet. So, but right now I'm going to focus on the blue ocean event and the ramifications if that occurs. So in part one of this two-part series of videos, I said if you Google Arctic sea ice graphs, there's loads of information on what is happening in the Arctic. And just as a reminder, I'm Paul Bechwith, University of Ottawa, Laboratory for Paleoclimatology. Please follow my YouTube channel and have a look at my website, paulbeckwith.net. And please consider a donation to help fund my research. This is all done and paid for by myself. I'm not getting any funding to do any of this work, and I've done over 100 videos. So if you Google Arctic sea ice graphs, you can see this type of thing, and you can see up-to-date information on the Arctic. Now, last video I talked about this spiral going downward towards the center. These are all the different months, and this is September going down here. I also showed this plot, which shows each month decreasing. And if you do an exponential fit, this is the trend line here. And here we are in September. And if you do just take this particular data for this is the average over September, the average ice volume over the full month. And if you go to the yearly minimum ice volume and do a linear fit, it extends out a bit more. But what's happening this year is the Arctic sea ice extent is decreasing much more quickly than it's decreased in any previous years, including the previous minimum, 2012, when there was a big cyclone that tore off chunks of ice and distributed it around the Arctic. 2007 was another minimum, and then 2015 of last year. So this is where we're heading. We're well ahead of the curve. So buckle up. You know, we're on a roller coaster ride. You know, where will this end up? One of these years, this will end up at essentially zero. And then we have a blue ocean event. And what does that mean for society? So this can go a couple ways. Okay, let's go back here. This can go a couple ways. So what I and others have been arguing is that basically it's well known that there's a very strong feedback. It's a reinforcing feedback that when we lose Arctic sea ice and snow cover, then it gets much darker in the Arctic. So during the summer months, the solar radiation is absorbed in those darker materials, heating them up, and that causes a decrease of more snow cover and more sea ice loss. And this is a vicious spiral that carries you down. So this very strong feedback makes the entire Arctic region darker, causes it to absorb more solar radiation and heat up more by itself. So one of the key feedbacks is it lowers the temperature gradient to the equator, which slows down the jet streams, makes them much more wavier, causes the increases in the frequency, severity, and duration of extreme weather events that we're experiencing. Now, this is not just a northern hemisphere phenomena. Because the northern hemisphere is warming a lot because it's darker in the Arctic, and it's getting more heat from the sun and it's warming that way, then there's less movement of heat from the equator northward. So this compensates. This heat can generate more water vapor at the equator, and for each degree Celsius rise in temperature, there's about 7% more water vapor in the atmosphere, but it will also transport a lot of heat to the southern hemisphere because less is moving to the northern hemisphere. And this is starting to bake places like, India, for example, in April, heat waves. Heat waves in New Zealand, Australia. This is a global phenomena, not just an Arctic phenomena. The whole climate system is connected. Excuse me. So the albedo feedback is a very strong process. But there's also another huge feedback process, and this is a latent heat effect. If you have a kilogram of ice and you apply energy to melt that kilogram of ice, you'll end up with a kilogram of water. Apply that same amount of energy that melted, that caused that phase change from the solid to the liquid, apply it to the liquid, to the water at 0 degrees Celsius that results from the melting ice, and that water temperature, that kilogram of water would raise up 80 degrees Celsius. So the ice acts as a buffer. It keeps it cold. It keeps the water around the ice at 0 degrees Celsius. When there's no more ice in that ocean, then all that energy will be absorbed by the water, and it'll raise the water temperature on the surface, and then it'll be spread by mixing and currents, and it will change the complete bathymetry of the Arctic system. The water temperature will increase, and the mixing will carry that increase down. Now, there has been arguments that there are some strong negative feedbacks. So let's have a look at the opposition view that, we will reach a state where we have no sea ice in the summers, at least for many months in the summers, and then it will reform each winter, and if we reach this state for a period of time. So this is an argument. So if we, on Arctic sea ice graphs, if we go to the Arctic Sea Ice Forum, you can click on Arctic sea ice here, and you can follow comments on the 2060 melting season. You can also go and look at the slow transition. Okay, now the slow transition forum talked about this possibility and of always reforming ice in the winter. Let me find the curve here. So this is a mathematical curve which is it basically describes the growth rate of ice versus the ice thickness. So ice is a good insulator. So if the air temperature is cold and you get ice forming on the surface, then it gets thicker. And the thicker the ice is, the lower the growth rate. That's what this is showing. When it's just water, it can freeze pretty quickly to a thin layer of ice, and then that ice layer gets thicker and thicker, and then gets up to, this is a meter, 100 centimeter, a meter, 2 meters, and so on. And then the rate of formation slows down. But this is an ideal situation where there's just where there's not much mixing of the water. So, in a lake, when the ice starts to freeze in the winter, when the air temperature drops below 0 and the water temperature gets down, it generally starts to freeze in the bays and areas around the shoreline that are very, very calm, and then it propagates out. So the ocean is a different beast. There's a lot more mixing of the water, and if there's wave action, it can be very difficult to form ice. As you know, in rivers, when there's a lot of water motion, the ice doesn't form. In the ocean, there'll be upwelling. Don't forget that dark ocean in the summer will absorb tremendous amounts of heat. It'll change the dynamics. There'll be a lot more clouds, perhaps, over the Arctic. And those clouds will stop the heat from radiating out to space as quickly as we might think, and keep the ice from forming. And the duration of the open water, the blue ocean, if you like, in the Arctic will get longer and longer, and the freeze-up period will get shorter and shorter. So if you follow the trajectories of those curves, of these particular curves, then the other months will come down to 0 too. And the biggest concern for humanity is how this can disrupt the global food supply, how it will affect the extreme weather events around the planet. There's enormous geopolitical ramifications of this. Also, these rapid accelerations and rises in temperature that we're seeing in 2016 are all related to this as well. So there's arguments for both sides. I, for many years, have thought that the argument for losing sea ice for longer